And welcome back to the Electronic Experimenter's Kit. Experiment 7, the monostable. Right, here we have the monostable. The monostable. Right, here we can see the basic circuit of a collector coupled transistor monostable, and we'll show you the waveforms later. When power is first applied, the base of Q2 is connected to the 5 volts via R4 or RT, because that's the resistor, that's the timing resistor, thereby turning Q2 fully hard, because its base will be pulled up to at least 0.6, 0.7 of a volt, and it will be fully saturated. This will pull the collector low, which will itself be then transferred to the base of Q1, making Q1 off. And this is its stable state. You might get, when it turns on, you might get a brief flash from here, but it will settle straight back into the stable state with D3 lit up. Now, when we see the falling edge of the input trigger pulse, it will pass through C1, and at the point here of junction of D2 and R3 and C1, we will see a negative spike. Ignore the slopes and that, it's hard to draw diagrams accurately in KiCad. But you will see a negative transition, and then when the pulse returns to the positive, you will see a positive transition. Then the negative one will be larger than the positive going spike, because the negative spike is just going to be generated across R3. The positive spike, the current is going to flow through D2 and then down through Q1 via the base emitter junction. And as we know, you're going to drop 0.6 of a volt across there, or so. We'll drop 0.6 to 0.7 of a volt maybe across the diode. So the voltage point here will get capped at 2 diode junctions above 0 volts. So that's physically capped by the diode junctions. That isn't capped, so it's free to spike as high as it can. That's why you'll see a bigger negative going spike than you will the positive going spike. And then if we move the arrow up to here, what we'll see there is we'll see a little positive going edge, but that will turn on the transistor, and that will then flow via this capacitor, and it will force Q2 off, and we'll explain what happens there in a minute. So what happens here then? We get the base shooting up to 0.7 of a volt, Q1 turns on, the collector is connected to 0 volts, so the capacitor that's got 0.7 of a volt across it this side, and it had about 5 volts across it on this terminal. When this falls down to 0 volts, this shoots down and it takes this point negative, because this was 5 volts and it had 4 point something volts across it. Now we've chucked it down to negative. It's still got the voltage across it, so it becomes a negative spike. So if we move the arrow, I'll say we're going to look at that point, what we're going to see here is this was held at 0.7 of a volt. When Q1 turns on, the voltage at this point, which is the base of Q2, suddenly shorts negative, turning this off, which brings the base of Q1 high via the 10K and the current path down here. But this capacitor is now charging through here, so this is going to stay low for the time period. So here we can see the voltage at this point, and as you can see, when it turned on, it dropped, and it stays low until that capacitor is charged up to 0.7 of a volt. As it comes back up from being negative, crosses the 0 volt line, and then it gets to 0.7 of a volt, the transistor turns on, this gets pulled down low, this goes down low, and Q1 turns off. And so the width of that pulse, or the width of the time that D1 is on, is determined by the timing factor of RT and the CT, or R4 and C2. So I hope this kind of explains what the circuit does and how it works. So now we'll go to the circuit and we'll have a look at that. Right, here you can see here's the circuit, LED 2, LED 1 there, the transistor there. This circuit's looking a bit different because on this transistor the base faces in that direction and not as in the circuit. So slightly different. And we have a little switch down here just to pulse. So what we do is we'll click the button and we'll bring the screen up for the microscope, so which is looking at the scope. There you can see we're hitting the button and you can clearly see there we have, as the negative edge drops, there we have the negative going spike, and then on the positive rising edge we have the positive going spike. And as you can see, the negative spike's quite big, but we've got 2 volts per division, and the positive going spike is being stopped at about a division, so about 2 volts or less. Now we move on and we'll look at the base, the other side of the diode. So this is the base. And now when we hit the button, now we can see that on the rising edge of the trace we get we had the positive spike on the base via that diode, and you can see the base has gone positive to about 0.7 of a volt for the duration that the light was lit, and then it comes down. And then so if we move the connection to the other side, it's quite a sensitive circuit. You'll see that as you move things around it will trigger, so it's quite sensitive. So then trigger the input again. Here we can see that Q1 collector went low when the rising edge of the input trigger went high, which caused the spike onto the base of Q1 going positive, which triggered it. And there we can see that that was the duration that the light was on for. And again, as we touch it and move it, we may trigger another event. And then if we look at the base of Q2 and we trigger it, back up again. Here we see here that as the input trigger goes high and Q1 is turned on, the voltage across C1 and Q2 base shoots negative, and then it slowly charges up by, I think it was R4 or RT, until it gets just above 0, and you'll see it's gone up about 0.7 of a volt. If I center 0 on the middle line, so this is now 0 volts, and we're on a volt per division. So it's gone up about 0.7. There's 1 volt, so about 0.7 volt, and that's when the system flips back. Well, I hope you enjoyed that. Looking at the circuit, a little description and a view of what's going on the scope. So that's it, folks. Hope you enjoyed it, and I hope you come back to see experiment number 8. Bye for now.